All right. I believe we are live. Yup, appears so. All right. Now for another exciting day of saying that we're implementing Rust traits, but actually doing other things. So, since last time, well, I haven't really gotten anything done since last time, but what did I get working last time? Right, I got spans propagating properly through the entire document. So now in our AST, when we actually run stuff, let me see if my history here. There it is. So when we run this now, we get complaints because I've been refactoring stuff slightly. But what we would have seen is an AST with like URIs of where each individual like construct of the AST had been from. So in that refactor there, the thing that broke it since last stream, the thing that I've mainly been held up on is I haven't been sure what format I want paths to be in, or how I want to construct modules. So, like, in Brane script, it's mainly, its main use is for, like, user-generated content, right? Which means it needs to be very sandboxed, and yeah, just needs to be very sandboxed. So one of the things I'm trying to decide right now is, like, should I allow modules to statically link in the runtime to other modules, which is something that they can do. They can statically link at runtime, because at the moment with LLVM, LLVM ORC on request compilation, I could load one module with functions in it and then load another module and have that module statically link to the functions in the other module. However, there's like potential security concerns of like, oh, what if all these modules are linking to the functions of other modules, and then like a common utility library gets compromised. Now all of them are calling utility functions that are compromised. It's like, okay, what if I just make the language have it so pipelines can't have side effects? But then it's like, but then the side effects that they want to do have to be returned to the pipeline, and then they're just going to execute those. There's not really a way to sandbox, like, compromised libraries like that. So I'm like, okay, like, one thing I definitely want to have is the ability to have multiple modules in the source code of a project, and then have those functions statically linked into the binary. So not statically linked at runtime, but statically linked in the binary. So, like, they're compiled in with it, but then you get like, oh, I have so much duplication of the same utility libraries. Which, I guess, you want it to be less hackable, or take up less space on the user's machine. I don't know, it's a hard choice. But anyway, and that all of that was like making me not sure what paths should look like. Because how do you resolve a path for like internally statically linked versus externally statically linked versus some form of like actor-esque message sending at runtime, which I want to avoid in the cases of utility functions, actor-esque message sending, because that's a lot of overhead for just like add 2 plus 2, or other similar, like run a hashing function on this. And like if you have imported objects from those libraries, like all of those little tiny member functions are gonna really add up if you do actor model for all of those. Anyway, but then I realized that's a question for a different day. With what we're doing now, with just adding intrinsic trait support, we're not like defining objects yet. We're just trying to get traits working, which means those traits will have some static path that's like an absolute path, or what's the term in Rust? A canonical path, the full path to the thing. And that's the only thing we need to worry about right now, is what does our full canonical path look like? And we can refactor that later when we actually go through and do like a full, what our path's going to look like in this language, how are our modules going to work, how are groups of pipelines that are potentially separated into multiple modules in the same thing going to look like. Maybe I just call them namespaces instead of modules, and then the entire compile unit is called a module. That probably makes a lot more sense. Yeah. But for now, that means that I can't ignore the path resolution pass, which is what I was like stuck on yesterday. So we're gonna put path resolution pass back in here. And then we're gonna go, I'm also gonna add module linking back over here, because we're not adding module linking, we're doing intrinsic functions. And that, I guess we can put this in block for now. But this is a lot easier to manage, just these three things. We have to do a desugaring pass to make it so all of our operators are just implicitly calling just like intrinsic. Brane, work with me here. They're intrinsically calling traits. Well, they're calling traits that are intrinsic, which means I probably need to this. Now I have to go back to the path. I feel like I now need to add this path format where it's like type as this trait. So like this would be like int as add and then call the add function. Now, do I need to actually support this specific syntax? No, probably not. I only really need to support it at the HIR level for now. But dang it, I'm right back to paths, because I know that I currently don't have a good way to call traits, like refer to traits. So I'm gonna go back. We're gonna look at the Rust compiler real fast. Specifically HIR, and then we're gonna look at, I guess, struct call. If we can find a function call. So there's expression kind call, which this is what we're looking for. Ooh. Can I please I have to expand this because it keeps reverting my place in the thing. There we go, finally. And this is an expression, and then a array of expressions that are the expressions to call. And then we have method call, which I'm probably going to even desugar method calls to be even simpler than this. Like, they don't need to be two different expressions, at least at this point in time. Because all it really is you have a self argument. And then that self argument yeah. You can desugar a method call into a regular call. Yeah, so this is the expression, this is the path segment. That is just the call to the method. At least I think it's fairly easy to desugar. Okay, so I guess we have to look at expression. Well, actually, we're already in expression kind. So let's look at path, because path is what we need to look at here. And this uses a qualified path, and qualified path is what I want to look at. So there is, and I haven't actually looked at the HAR too much, just the AST. So here we have a resolved path. And this is a fully qualified path with a self type. Oh. I guess I really only care about like the fully resolved path, which is optionally a type and then a path. But what about a how do I handle stuff like a trait of type? Because if I go to the AST, and then here we look up, there is no Q path, there's just go to expression kind here. Here, I'll just use this little lookup function there. Somewhere in here we'll have a path as one of the expressions. If I can find it. Ah, here it is. So optionally there is a Q self structure and then a path, and path is just path segments with potentially arguments, and then that's the type that it's qualified for. And then it has a span of that's weird. So they're only storing the span of the trait, not the trait itself as a like fully resolved object. Which I find strange. Here we have type and then path. Type relative. What's the difference between a resolved type optionally fully qualified with a self type? So if you look at path, yeah, it just has path segments. Then segments are just an identifier, optionally have generic args, and optionally have not inferred all of their args. And then if we go back to expression, see, I'm not seeing them handle their own language concept. Or maybe they just don't do fully qualified paths in the actual HIR, even though they let you define those. Yeah, I don't know. Path to definition, possibly containing lifetime or type parameters. Represents the method name, and as generic arguments, the is the actual object, and that's the arguments. That makes sense, but I don't see like a place here to put an optionally qualified trait. Unless... No, because there's no type here either. There's no way to fully qualify this. First field resolves to the function itself. I mean, this could be fully qualified. Because this is a place value of a specific function. So I just need to parse out how qualified paths work. What is a lang item? I don't care about that too much. So we have type relative and resolved, and one of these will be, yeah, optionally fully qualified with a self type. Example, an unqualified path like clone that's the clone trait, has none for self, while vec as clone has some vec t for self. Okay, so this is the qualified path here. Is optionally we have, this is straight up a reference to an implementation. Like a trait or an object. And then this is optionally a qualified. See, I feel like it would be the object, not optionally, but then again, I guess the object doesn't have... In this case, the object doesn't have a member clone. The trait clone has a member clone, and then you need to say that type as a clone trait, as its own clone trait. So why do you also need type relative then? Because it seems like this. Well, let me just see what path is. Path is just a bunch of path segments and then a resolution. So this can't contain anything but identifiers and some generic args. Okay. I basically understand most of what's going on there now. So, let's go into HIR real fast. And what we need in HIR is basically we're going to rewrite this to blatantly rip off Rust, because I'm sure that for this part of the language, they've designed it better than I could. Then I won't put in any infer stuff yet, because that's not stuff we're supporting yet. And we don't have generics yet, but I feel like we will have generics relatively soon, so I'll leave that in there because we can just put none there. I know, two very conflicting, like, oh, I'm not supporting that, so I'm not going to put it there. You know what, screw it. We'll be consistent. We'll put in all the features we're not supporting, at least for this one struct. So we now have a path segment. Path now. Yeah. Path. Struct path is just segments. Yep. And then the way that I'm going to resolve certain type paths is through linking parents like this. Actually, wait. I think I'm going to be doing path path resolution inside of the AST, not HIR. So for the HIR, we'll just have span and segments, and that will make our life easier. Do I actually want to have a resolved object, though? Is that something I want to do at this point? Or just have people always look up the... Or the caller always have to do a path lookup. That's something I'll figure out when I need to. There we go. I believe... Oh. Complaining, cannot move. Yep. There we go. No diagnostics, we are good to go then. I do kind of want to rewrite a lot of this to reflect... I wrote all of this before I rewrote the AST, I believe. I think. So this is a good bit of rewriting to happen still, but I think I can get back to lowering. I meant to put that on the other page, but that's yeah, that's fine. Yeah, so here we go through... And this is where I was also running into, like, how do I want to handle paths? How do I want this thing to... How do I want this whole thing to work, you know? do I keep these as modules? Because a module is like a thing that is compiled separately, right? I guess not in Rust. In Rust, a module is a namespace, and then a crate is what is traditionally known as a module. And these are kind of just namespaces. So do I want to make that divergence now? It doesn't change how I need to do namespaces, though. Then we need an identifier for this module, which would be node identifier. We need to keep track of the current scope. So I'm gonna add in here a pub the current path. And this is going to be a list of scope segments, or path segment. Does this need lifetime generics? It does, okay. Do I want this to be optional? No, it's a vector, it can be empty. So in here, self. Current path is just going to be vec new. Then we're going to let well, we need to do a couple things here. We need to increment the current path. And for incrementing the current path, I want to have a path something like a path scope guard. Oh, actually, you know, it'd be perfect for this. The fur macro that I have sitting in the project and not using it for anything. Then we'll push a current path. And what we need is an HIR identifier and optionally a list of generic arguments. So we will do ident is HIR ident, and args is option HIR generic arg HIR, and this needs to be a vector. I don't know if I'm gonna also make it a slice like the Rust compiler does, but yeah, I don't know. Okay, and then we're gonna say self current path push well, I guess just a path segment, so I don't need to do all this. Since we're gonna need to define a path segment already, let's just do when I refer to path segment, okay, I don't have this as a mutable reference, so we're not allocating these in the arena. Though technically we could allocate these in the arena. Do I want to allocate these in the arena? Yes, I probably want to allocate these in the arena. Which means now in HIR arena with types, we also need to put in path segment. I am so glad I made that macro. You see, now I can tell that this doesn't need to be its own function. You could just self current path push. Actually, with defer, this won't let me return it out to a different scope. Dang it. Be kind of cool if it did. Expected unit type found option. Do have a semicolon. Okay, let's try drop. Just explicitly drop it. And that seems like it's happy. So let's do path segment for this current module. No, I didn't want to run it. Different keybinds, different actions. Very similar keybinds, different actions. Okay, so we need the identifier to put in here. For now, args are going to be none. Infer args is always going to be false. For now. So the ident is going to be self arena. Allocate identifier. Can't remember the keybind for actually showing off info. There it is. Okay, so that does just take a identifier. So we need the span, which this will be just node ident span. And the text will be node ident. Ident. To string. What? Okay. And then I'm gonna separate this out into its own thing here. I don't think it's possible for this to fail, so we're gonna make it not a result. Cool. And now we don't ever have to write that out. Self lower ident node ident. Man, it was not happy about that. Ah, okay. Now it's happy. Then for path segment, I'll keep it as that for now. I don't want to mess with the macro. Then the ident, I think references are copy and don't get moved, so this can just be ident, ident, then we're good to go. And then we can just do self current path push, path segment. And then we just defer till the end of this scope, dropping of that path segment. I feel like these two lines of code here are fine to copy paste. And then down here, self arena. Allocate HIR module. Yep, ident isn't complaining. Span is just node span. Is it copy? I don't trust it. I'm gonna put a clone there. Oh! What are you doing, Vin? What are you doing? Then when we actually insert this, we need to insert it into the modules with its full path. So I'm gonna say self current path. I want to do the displayed version of this. Which means... Huh. I'm trying to decide if I want to put an actual path here, then have the, like, make a display for the path and be that can be how we can do a 2-string for this this insert here. Yeah, it's just a span in segments. We already have a display for path segment. Oh, I already have a display for path. Huh. Well, that makes this super easy. Since I already have that display for the HIR path, here in current path, what we're going to do is to just say this is a HIR path, like so, and then in our arena, we're gonna add path to the list of allocatable things. Scope guard is a lot more. I think scope guard is closer to what I want. Scope guard with a value. I think I want to be able to return an object. I don't want to have to actually write out a scope guard though. So yeah, I'm gonna switch to scope card from defer. It looks like there will still be defer statements. I don't think I'm actually using defer statements anywhere. So here we're gonna go. Oh, did I put spaces? I did. Cargo add a scope guard. Cargo remove defer. Okay, cool. That just works. So now, instead of the defer macro, so I can still do push path, and this will take in a path segment. And this needs to become an option. Oh, I forgot to actually name the variable. That would do it. Wonder why that's complaining, though. Oh. It wasn't. It was just my LSP being slow. You're gonna say old path is equal to current path, and I'm actually going to take and then we'll say self current path or actually we could swap. Swap the current path with segment. Or no. I can't get that fancy. Unfortunately. No being fancy. I hope I don't have to turn this into a macro. Yeah, we'll still try to get pretty fancy. Don't worry. I wish I could do just implement function once like that, but Rust generally doesn't like nested implementation traits. Does that work? Can you infer return types? Oh, I think you can infer return types. Nice. All right, so we have old path. If let's match on old path as so if there is an old path, what we want to do is we want to return a scope guard, which is we're going to return scope guard defer. And on defer, we're going to set self current path equal to old path. And I think I can actually do this for both. Actually, we're not going to use a macro. We're going to use the explicit function call because I trust that more. And the reason I'm going through all this effort to make it a scope card is because I know that I'm going to forget to decrement scopes at some point, so it's just good to do it this way, because this means I don't have to remember to do anything after this. I just know that it will always work correctly. So here we have old path, and we want to do, actually want different match arms. I'm going to be a little fancy. This branch needs to return none. This needs to return path. And in this case, a self-current path equals path segments clone segments push segment, and then self current path equals the arena alloc path. And in here we put a path, or specifically HIR path. Fill all those struct fields. The span of this is what is the span of this path? I guess this path doesn't have a span. Why am I allocating a reference to span there? Doesn't make sense. I guess I'll just copy the span of whatever current segment. like that, and then here, here we'll do the same thing. Which I guess, technically, I could throw this out here. And then for segments, we just do vec. Can I type a square brace? There we go. Vector of segment, like so. No type span on path segment. What about on the identifier? Does the identifier have a span? Yes, the identifier does have a span. Streaming right now, what is it? Okay. Okay. Wingspan? No. Different type of span. This is a code span. Has both range and source. Alright, if I understand my own code correctly, there, one second, I need to turn a light on because the sun will no longer give my headset tracking soon. There we go. It's always fun when I get the little pop-up like, the darkness threshold has been reached. Hopefully that's a nothing error. But here, if we do push path, theoretically, we'll have a path guard here. Say self current path, but actually format. And then the current path. Actually, I could just do self current path to string. The theory is there. The functionality is not. Oh, wait a second. I know what's... Hopefully this expect doesn't fire. I'm hoping this path segment stays in scope for the length of this function. Actually, I want to try it with that first. So let's try getting this compiling and see if we can start just making sure we have all of our code tied up so we can start testing this. So here is our AST. And then we want to do AST lower in context and then call lower on the AST. And theoretically, it's as simple as, oh, I also need a HIR arena and the error emitter. Do I currently still create an emitter? So you have the AST, let HIR arena equal HIR arena. And we should have HIR now. Now let me check if I actually have display for all of my HIR or just... I actually do want HIR to be displayable for debugging. That's not complaining, which is suspicious. Which requires computing the function signature of that. Okay, so I somehow created a recursive type for it to figure out. Can I put that in there? Well, that I don't have to do that one. Oh, okay. It's because I actually gave it an argument, which was HIR path. Like that, and then the function once also needs to accept that same argument. That also needs to be an HIR path. And the reason why I'm keeping the namespace as AST or HIR here, even though it is a fair bit of work to type it out everywhere, is because this is the lowering function. We have a bunch of classes with the same name existing in the same space. So I just want to make sure that we're not getting like the AST path and HIR path mixed up. It's for readability. Hello. Yep, things are going slower than I'd like, but smoothly. Captures lifetime that does not appear in bounds. Can I say that this function is the lifetime of the caller, like that, and then it will be allowed to capture arguments? It looks like it is actually happy with that, which means technically I don't need to pass in old path as an argument. I could pass it in. No. Since we leave this scope, we do need it to... Yeah. In the future, what's the perspective on someone porting over an avatar from VRC? I haven't fully figured out how avatars are going to work, but I am very interested in spending some time figuring out like a auto porting utility. So that would be like a Unity package you throw into Unity, and then it automatically like, oh, this is like the VR chat fizzbones. Let's, on the Brane side, convert that over to a replica of that system built with like BraneScript, for instance, and just do that for a bunch of like very common things. And it looks like certain shader creators like Poyomi, for instance, are already working with Basis, so they're already interested in like working with other platforms to make it easier to port their stuff over. So it would be possible to like make a port with a Poyomi shader and then have like all those properties also carry over, because like shaders are the thing I was most worried about, and then I saw like shader creators being like actually open to working with external non-VR chat platforms for the purposes of porting stuff over, and I'm like, oh cool, that's actually less of a concern if they're like chill with you just cloning their shader, porting it to your system. Wait a second, for this, or path segments, not, yeah, let's make these references. Yee, super cool. Anticipating the April Fool's Day where you announce Brane Engine, the most neutrally flavored of game engines. Or Brane Engine. I'm not sure what neutrally flavored means in this context. Not implement the copy trait. Oh. Yeah, this only needs to be a reference. That's the most neutral of cereal. Oh. I mean, brand cereal definitely succeeded in being true neutral cereal. Argument requires that ident is borrowed for HIR. I mean, yeah, that's the... because it's also borrowed as immutable. It's the path segment. Ah, okay, okay. So I have to choose whether I want this to be immutable. Well, if I have it all over the place, I guess it has to be immutable. And then if I want to change the ident, I guess I just swap out the reference. It's just a box room. Yup. Oh no, Brane is gonna have a ton of unnecessary features. What do you mean? The scope creep I already have right now. Alright, we're at the point where we're getting errors over here. I mean, AST doesn't implement debug. I've already been printing AST as debug. Do you mean like the struct AST that I've only created recently is not debug? Looks like yeah. We'll derive cloning debug for that. And would render the box at 1 frame per hour, a new record-breaking speed. I don't know if that would be record-breaking. I feel like, if we're going for longest render times, like, look at the old Pixar movies. They would take, like, days to render a single frame, and the only reason that you actually got a movie is because you'd have multiple computers, each one working on a single frame. So that should fix the problem. Well, actually, let me write all just to be sure. Yippee! It's happy now. Okay, now this expected arc found. Oh, right, because I want emitter to be trivially copyable. Trivial for the coder, not trivially copyable as in like the coding term trivially. HR does not implement a format display. Alright, do we want to take 30 minutes here to implement display for format? Or display for format. To implement display for HIR. See, for all of them to be linked together, you'd have to have every single asset within them be interoperable. Or you'd have to do something like... So this is what the Basis ecosystem is kind of trying to do. Where Basis is not a platform, Basis is a framework. You build games and platforms on top of Basis. That's why it has the name Basis. And... some people on, like, in the core community want to eventually extend this to where every Basis experience works with a common executable switcher, almost, to where there's like a portal in one experience to another experience, and when you go through the portal with your group of friends or whatever, what happens is your computer will then close the current experience that you're in, like the entire executable, and then reopen a new executable. And then I'm guessing there'd be some form of like state data to put you in an instance with everybody who is already in that other instance. And that's how they were going to do interop between separate platforms. I'm personally like, that is a really cool idea, but it'd be like super unperformant, super unergonomic. I can see tons of different ways where like the executable just wouldn't open. There'd be a lot of debugging to get it there. And I'm kind of like, what if we just made everybody make stuff in the same engine, and that engine had interoperability by default of how like assets are created, which is the route that I'm going. I think it's the route Epic is going as well with like their verse language. Which I actually sent an email to them where it was like, hey, when you're like down to let third parties try out first. I'd be down to test that out in my stuff, like at least try putting it in, to increase the interoperability of different platforms, because I think that makes sense. But yeah, we'll see. We'll see where that actually goes. But I think interoperability is going to be like a part of the engine thing, not a swapping between executables sort of thing. Like everything are like browser style interoperability. Software version of the headset's going through the hardware version console wars already. Yeah, software version of the console wars. So do I have to put the display trait in this file itself, or... Do I have to define lifetimes for this? I do. I'm gonna try to do... Oh, what's the name of the thing? So there's linear and affine. Yeah. I'm gonna try to do affine types without lifetimes. This is my goal. I have a loose idea. I don't know how I'm going to handle collection types yet. But for any like non-dynamic object, I have a pretty good idea of how I'm going to handle like references in a way that potentially will be a lot more understandable than lifetimes and extendable. We'll see. I'm unsure. We might just get... I definitely don't want to have lifetimes. Like, I don't want people needing to annotate each individual type. They might need to annotate like the return types of functions in certain very specific scenarios, but for the most part they won't need to have like actual interface or lifetime values with what I'm currently thinking. All right, and then for HIR, we're just going to do self modules. Then we'll do fold. And then initially this is going to be okay. Or not okay, this is going to be a string. This is going to be text and the actual module. Yeah, and then we're going to say format. I know this isn't the most efficient way to do this, but it's the easy way to do this. Format, And then text, and I'm going to do a new line between each module. Maybe I want collect, not fold. No, not collect. Reduce is the one with the... No, it is collect. No, not collect. Fold. It is fold. Two positional arg. Oh, that's what it was complaining about. Wait, I could do this easier. I could just pass in formatter. Trying too hard to be fancy about this. Actually, I could just map error this. Okay, did you lose some brain cells there? Because I think I got splash damage from that. Real. Yeah, I'm putting way too much effort into this draw function. We're never going to get through the entire document at this speed. Now it's going to complain. There is no display type for module. And I can keep the same exact code there for all the modules in module. Because modules have modules in them, right? Actually, not in the HAR. So here I would do right, and then I want this to follow the format of like unsugared, like fully unsugared version of this. So this is going to be module, then the identifier. Then a new line, and then, oh, right. This is a format statement, so we need to do double curly braces. Hey, LSP, could you stop being the slowest thing on Earth? I have to split all these crates into different modules, don't I? Or split all these modules into different crates if I don't want my check to take half a century every time. Then in here, I guess I want to do just pipelines. And we can just, in here, do format. That string. And then a new line for the current string. I'm going to assume it starts on a new line. So we're going to do that. So text. Then a pipeline. And that will fold out all pipelines. And pipeline doesn't implement display and identifier. I think identifier might implement display. Yeah, display for ident. I forgot to actually put in the formatter. Now that's happy. Not. It just isn't done compiling. Get a nuke modules. And then we are going to implement display for pipeline. Just throw in some reminders there for myself to implement stuff later. And then in pipeline, ooh. So we do here pipe, and then self ident. And then we do self callsig. And callsig should have its own display trait. And I'm gonna leave stages at stages not displayed yet. Just to kind of cut off the amount of stuff that I actually have to write here. The amount of display traits. Eventually we will fully implement that so we can debug paths. So now we implement this for callsig. Which is going to be braces and then optionally a return type. So I think we'll go if we'll match on self. Actually, this is desugared. Well, actually, have I resolved return types yet at this point? It's possible that I have not resolved return types at this point. I don't know. Right now, you do need to do return types, so I'll just leave it in here. So that's our return type. These are our arguments. Oh, wait a second. I want to first do a map on args to string. So we format the actual arg itself. And then we do not a fold. What's the other fold? Reduce. And this is where we add in commas. So this will be format. Then here we just do args, and then self output, which is a struct definition. So now we have to do display for a struct definition. Oh, wait, right. Input is a struct definition as well. I think I'll just do members for now. So now this is complaining that value doesn't implement display. See, this is one of the things that I wanted to refactor to be closer to how the AST currently has it. Because the way that the AST has this is super clean. That's super weird. Where's my keybind to restart the LSP? Apparently no keybind to restart LSP. So we just have we just get to deal with this. If I go over here, yeah, see, look, there's my keybind for restart LSP, and if I go over here, it doesn't have it. How do I close a buffer? So that should be fully closed now, so if I reopen it, there we go. Yeah. So, somewhere in here we have not value. I'm probably basically gonna straight rip like type and boot type, unary operator. Let's see, what is used by? Used by type kind. And I like this format of storing this a lot better. Boot type and then somewhere in here we have field, which is like box expression identifier. There should be field definitions. Yeah, struct expression, field expression. Should be just field somewhere. No, there's only field expressions. What for struct definition? Where did I define structures? It's the AST. Here's the function. Here's the call sig function return type. Which am I going to keep on the back end, them abstracted as structures? Is that something I want to keep that way, or do I want my runtime to be able to handle that? I think in the IR intermediate representation, I think I keep them as structs because that keeps it really simple on the transmission side, and then the implementation can the implementation of the backend can decide how it wants to handle that. And then here on the code side of things, so I have struct expression, which has a path. Did I just never define a structure type? I didn't. Because I have anonymous structures, which are the only structure I'm using so far in the AST. Yeah, that means right about here. Right about here, I want to define a structure type. But wait, I still need a... Okay. So, one type of types, one type kind can be a structure. An anonymous structure. which currently I only have as an anonymous structure, but this could theoretically also be a path to an actual structure. So this is how I'm currently defining that. So I guess over on the HAR side, I do need to create a structure type. Okay. See, GitHub, it's completely useless when you give me that pop-up. And then reset the position when I close it. So here we need not a trait object. Oh wait, this is AST, not HAR. I want the HIR. I want to see how they represent it at the lower level, even though I'm probably doing my high level IR is lower level than their high level, or no, probably. No, I'm honestly not sure. They've infer. Let's see, in this type kind, did I have infer as well? They do have infer here as well. I don't think I copied infer though. At least not for now. Never type. Interesting. Okay, I guess looking at this, what was I originally looking at? I've kind of just zoned out at this point. Right, I wanted to see what their structure definition looked like. So I guess that's just their path. That's not gonna get me anywhere. Ooh, item. There's an item kind, and in item kind there should be structure. Variant data. What is variant data? So both structure and union. Oh wait, do they not have an explicit structure type? It's just this variant data for the actual members. And then they have union. Yeah, it looks like their syntax for union is exactly the same. Wait. Is it? Oh, I guess you can have a tuple struct and also this type of struct. And you also have the unit type. So you have the fields, a field def. I think for now I will just have a I do want the HIR to be more structured than the way they have it, because it's like a lot harder to do lookup of things. Or is it? I guess you could just do maps for stuff. I just don't want to have to recreate an entire data structure almost exactly the same. I guess there is some desugaring that goes on. I know for sure that I do want to refactor types to work the same way. So, I don't know. Do I copy huge swaths of AST and then throw it in here? And it's just like, we don't have binary and unary operators, and that's the only difference. Well, I guess the big difference for Rust HIR versus AST is that the HIR, every single one of these nodes, like if I go to field def here, each one of these has an HIR ID. And this will take you directly to the node of the ID. Or like, you can essentially do lookups on stuff. Let's see, struct HIR ID. Then you have the, oh, you have like ownership. But then you have your local ID, which I'm guessing. What is the definition of item local ID? Item local ID from the HIR ID crate. Which is from the def ID crate. For us to see span. A lot of implementations. There's like the root implementation. where's the actual... There is no using statements here, so this is the file it's defined in. Ah, here it is. It's a def index. Why are these types nested so deeply? There it is. Const crate def index equals 0. And it's defined within a macro. What is this? Why can't you just say like I32 or something? Or I64 or whatever. I don't know. But yeah, basically, there's an HIR ID. This ID, I assume, is put into a hash map somewhere, and you're able to look up the actual things that stuff is referencing. So like, this is the HIR ID of this field definition itself, and then you also have ref. Which reference is things. Wait, where am I right now? This is the HR, yes. Yeah, oh, resolution, res, not ref. Come on, GitHub, do your thing. There is no struct R. We import it from somewhere. Maybe it's an enum? There is no struct type R. But all of these are resolved to R. And then this does have resolution, like a res object. And this is in HR def, yeah. That's so when they lower to HIR, they actually resolve everything's references to each other, which is cool. Do I want to do that? Doesn't make sense to do that. I think it does, because that's going to make doing any operation on all of this a lot easier, because there will already be like Yeah. Which means now I need to refactor this data structure. Yippee! So now I'm gonna have an HIR ID, and this is just gonna be AU64 for now. Yeah, so path currently works the way I want it to. And then type is where that breaks down to this does not work the way I want it to. So I'm going to go to AST and just copy it. I did create a QCell. Not sure what I'm going to use that for yet. Then we also have the type, borrow kind, mutability, mute type. All of this gets yoinked straight into HIR with absolutely no changes. Except for we changed the lifetime name. Oh, it's complaining about no debug. Don't know if that's how I want to deal with const data. Oh. That's why I did that. Just so my arena would work. Because it can't detect what should have lifetimes and what shouldn't. I don't need that to be partially equal. Here it is. Struct. qualified path, expression field. And then struct tail expression? What is a struct tail expression? Oh, okay. It's one of those. This is like use defaults or unpack one struct into another struct. Got it. So then it just has a bunch of expression fields, which... Yeah. Identifier, expression. Use shorthand. Oh, shorthand as in... They don't explicitly specify the type. So I guess this is just desugared and then they keep a boolean there. Did I explicitly make it a field, a param instead of a field expression? Not type kind. No, it did have it as field expressions. Interesting. So I was the one who called this a parameter. I would prefer it to be called a parameter, not a field. The name has grown on me. Wait a second. Wait a second. This isn't an expression. This is a type. So type kind, when we do, where is structure? Well, I guess since Rust doesn't have, well, no, Rust does have anonymous structs. It's called tuples. And then it was just had types. There should be a struct expression though. No. Wait, right, because they don't have a an anonymous struct as a type that you can construct. So they could have tuples, but not tuples with named fields. And I very much want anonymous anonymous structures. Because I do have field expressions as actual expressions, so I think I'm just gonna copy this over. And throw that right above pipeline stages. Is it gonna claim that this life? Yeah, it is. Rust Phantom. There we go, everything has debug now. I guess this doesn't need to be mutable. We can just construct new HIR if we need to on passes. Okay. Now let's figure out this HR is oh, so they're using ident for all the way back from tokens. How do they define it? Ident symbol. What is symbol? They have the ident that is just a span. Yeah, they just have it identifiers as a span, so that they don't have so they don't reference the source code, I guess. I guess that makes sense. You don't have to carry lifetimes through your code if you do that. Like here, if on my AST, I think the only thing that uses a source reference in this entire document is the identifier. Yeah. And how many of these are there? Over 99? And there's just source references on everything. And you're saying I could have gotten away with not doing that if I had just done what they did here and have identifiers only be a span. You know, I'm very tempted to do that, because that just completely gets rid of a lifetime. All of these, all of those could just be gone. If you're just like, hey, so you know how you already need the source code for debug information? Yeah. You could have just not had that referenced. I'm very tempted to do that right now. Okay, yeah. We're doing it. We're nuking it. Then there should be one error. What? Why? I said global. Blah. Oh, this is tokens. I mean, yes. Now I want to get rid of the lifetimes on tokens. Do I want to keep the lifetime on tokens? Or do I want to just say, grab it from the span? Well, if I'm doing that for the AST, I might as well do it for here too. I guess I can't accurately pretty print this anymore, which is unfortunate. Because there's no point in having display for this anymore. Only debug. There it is. And I guess this is why they resolve it in the lowering step, is if... You have the span, you have the segments, path segment. Then if it lets us go to the segment, there it is. You have this identifier, which is, contrary to my belief, is just a metavar kind. Oh. And are you able to import members of enums into, like, a using statement? It's not letting me copy. Oh, there we go. Is that showing up on stream that I'm not able to select stuff? Huh. Just see span ident. So it is literally just a span, like a range. There it is. So now I need to wonder what symbol is. Internally, a symbol is implemented as an index in all operations, including hashing, equality, and ordering, operate on that index. The use of rustc index new type index means that option symbol only takes up 4 bytes, because rustc new type index reserves the last 256 values for tagging purposes. Note that symbol cannot directly be a rustc new type index because it implements a format debug equivalent in special ways. Okay. So they like combine every single string. I'm guessing they have like a hash or index of every single different identifier. And then they give that identifier the index of that symbol. That way you're not dealing with any strings at all, you're dealing with the index that points back to a certain string. Which is what I believe is going on here. Because like they have this identifier printer class. And you can print out ident name in the span. Do not use this. Do not use this. Do not use this either. Why is it there if you're not supposed to use it? Okay, my order of operations of things to do right now is simple. So I'm gonna add a couple more things in here. We're going to finish removing life string references from AST and tokens, because I very much like not having those there. Potentially create a map of all strings and assign them symbol IDs. I might just steal that. And the other thing that I want to do is break project into more crates. To speed up the LSP, because right now the LSP is pretty slow. Like, I'm constantly complaining about it, and I think the easiest way to fix that is to just split everything up into more crates, because obviously that's what they do here. So I'm just gonna do that, where each little thing that's mostly independent goes into its own crate. And that will hopefully significantly help my development environment so it doesn't take however long this took. Usually it outputs like a little... was able to do this in so many seconds. Also might be something with my Vim environment, but I'm going to try this organization tactic first. Alright, those are the things I'm going to try to do. But I'm like getting pretty low energy at this point. So thank you all for watching. This has been this episode of Blatantly Ripping Off the Rust Compiler. And I hope you join us for next time, where I'm gonna try to do some like power working off stream to just like get us through all this plumbing to the point where we're actually doing interesting things. Like, I find this interesting, but we're kind of like, oh, how should we represent paths? What data format are all these data structures in? And then like just doing a ton of data structure work. But yeah, until next time, I'll see you around.